please consider sponsoring me on Patreon. Link is in the description. You'll be helping me to build open source innovation automation solutions and also develop a low-cost 3D metal printing project as documented on my other YouTube channel, Calabal CNC. Thank you. Hey guys, gals, so here we go again. Okay, so some things I'm going to change with this architecture. First of all, instead of using Baron or Duke, I'm just going to go ahead and use Lord. So Lord Commander. I know it sounds a little cliche, but it should work just fine. Another thing I need to change is make sure that I include the date stamp and all of that information in here. I think I missed that, so we're making sure we add that. And I'm ready to go ahead into the rules. We're going to start working on the string parsing. So a couple things here. I do need to include a note here at the top for developers. So note, do not directly import this library into your script S. Okay. Oops. All right. All right. And please call via the rulebroker.js file. That clarifies, because of course that's actually going to do the unification of the rule sets. Okay, so let me go ahead and fill this out. File string parsing.js module is string parsing, and description contains all system defined business rules for parsing strings, values, arrays, and values of all kinds with various operations. Okay, so some of the requirements we're going to need. Requires, this is another one we haven't written, but I'll go ahead and write it right quick. Module configurator, which will basically be responsible for like saving and and retrieving configuration settings. It requires a module loggers. Again, that's something we need to write, but we haven't written it yet. Requires module basic constants. Okay. Requires, this is some of the stuff we've already done. Module. We're going to have a little bit different set here. So basic constants, generic constants. Just because this library has a little bit higher diversity of things. Requires module and word constants. And requires module system constants. Okay. Then we're going to have a few others. There's going to be a read line that requires module. Let's see, actually it's not module, it's a link at link https www.npmjs.com package n read lines. Okay. Requires again another package, external package, link https npmjs.com package and Lodash. This is another one. Okay. requires at link https www.npmjs.com package and path. I think we've got that one already in the other one, in the other files. Path. And another one we're going to need is at link https. Oh, this is not that one. This is mathjs.org. Index.html. And the package is just called math. Okay, and then we have yet another one at link https npmjs.com package chalk, and this will be used for colorizing some of our messages out to the output. Yeah, chalk. Okay, and then we have our data module data. Okay, and we sign it. And today's date 10/16. Okay. And then we'll have the copyright. Let's see here. Okay. Perfect. All right, now we need to do the imports for those. Import configurator from executioner configurator. Okay, we'll have to go ahead and implement that. And let's see here. That goes under, well, we haven't created a folder for executioner yet, so let's go ahead and create that. New folder. And here we'll go ahead and create a new file for the configurator. Configurator.js. Okay, so under the configurator, we need to do much of the same stuff that we've been doing. We need to have a header and file configurator.js at module configurator at description contains the functions necessary to set and get configuration settings from the shared data structure. Okay, some of the requires here. Module loggers. As you can see, the loggers is going to be important. Requires module word constants. Why can't I spell properly today? Seems like every day. Module system constants. Okay. And of course, we're going to have the path again, external at link https package path. Okay, and again requires data, and then we sign it. At 10/16. Okay, followed by a copyright and okay, well, I'm not going to have any notes that's there. There's nothing really all that important. Import loggers from loggers, because that's also going to be in the executioner folder. Import star as w from constants word.constants. Okay, and system constants. Okay, and of course we're going to have path equals require path. Var d equals require resources data. Okay. And that's pretty much it for the requirements. Now, yeah, the function, these are the functions we're going to need to have. Set, it's just basically setters and getters. Configuration setting. Configuration name, that's the name of the configuration setting. And the configuration value. Okay. Oops. Okay. So the other function that we're going to need is, of course, the getter function get configuration setting, and we'll just have the configuration name. Okay. And of course, we just need to have the export block for those. Set configuration setting and get configuration setting. Okay. So now that we've got those, let's do the headers for those. At function set configuration setting at description sets a configuration setting on the configuration subtree data structure stored on the D data structure. Okay. All right. Then this is the data types. So this is going to be a string. This will also be a string. I mean, technically it could really be anything, but we'll just put those there. The key of the configuration setting. That's basically the lookup or unique descriptor. The value of the configuration. Okay, and then the return is a void, of course. And then we go ahead and sign it. Date. And that's it. Okay, come down here. Again, we document this one. Add function. Get configuration setting. Description. Gets a configuration value based on the configuration name. Okay, this also is going to be a string. The key of the configuration setting and return type should be a string or an integer or a Boolean. Those are the most likely configuration options. The value of whatever was stored in the d data structure subtree. Okay, and then sign it. And the date. Okay. All right, now the implementations of these is pretty simple. We just take D and then access that, and it's going to be the w.c configuration instance, and then we just do the configuration name, what was passed in, and we set that to the configuration value. And that's it. And from here, it's also kind of similar. There is, however, some logic that has to be implemented here. So let return configuration value. We're going to sort of declare that variable. If we need to know if this thing exists, w.c configuration setting is not undefined, because there's the chance that we call this function and we're still in the process of possibly loading our data or loading the configuration. If d, again, we need to dig down a little bit deeper and check w.c configuration, and then we look at the configuration name. In other words, does this thing that we're looking for exist? Name is also not undefined. Okay, if that's true, then the return configuration value should equal D. Now we're going to access that thing, and it's basically just this and the same thing, configuration name. So if it's not nothing, then we should be able to return it just fine. There is the else condition, and then we just have this equals undefined, and we can change this up if we ever need to. Else, if we need to return error codes or anything else like that, there's ways of enhancing this to make those improvements. But that's pretty much it, and then we just return. Okay, so it's a fairly simple implementation, just a little bit of logic to protect ourselves, and yeah, that's the end of the configuration. And so I think we can come back here. This is the configurator now, and let's see, the string parsing, and we're going to go ahead and import the loggers from, let's see, it's the same folder structure, executioner, loggers, but we're not going to implement that right now because it's a fairly significant implementation as well. So we're gonna dedicate an episode to the loggers because there's also we're also colorizing. There's a significant colorizer component to the loggers, and we want to talk a little bit about how that affects architecture. But we can go ahead and go to import star as b from constants, basic constants, import star as g from same generic constants, star as w from word constants, import star as s from constants system dot constants. Okay. All right. Then we're also going to need const line by line equals, this is that the end lines, require n read lines, const, and then of course we got our Lodash equals require Lodash, and then we do var path equals require path, and var math equals require math. We might be able to get away with this, math.js, sorry, there we go, and var chalk equals require chalk, and then finally, or not finally, but var d equals require framework resources data. Okay, and then this is going to be forming part of our log system, but I'm going to go ahead and implement it globally now. Of our base file, base file name equals path dot base name module dot file name path dot extension name, and that is module dot file name there. So we're going to use that as a base file name, which forms a basis for our logging system. And now we do some very basic functions as part of our business rules system, the string parsing business rules. And by the way, the format for how we write code for business rules is a little bit different from how we write regular ones from other function libraries. So here, we're not going to do an export block. Like, we're going to just export each individual business rule by itself. Because this library can grow, and it's going to grow a lot, and it has, and it probably will continue to grow. So rather than maintaining and managing an export block that's by itself, we just have a standard template here that we implement for each business rule / function. So export const string to Boolean, and these things are needed for loading our configuration data or parsing our configuration data. Input data, metadata, and we're going to have a standard format for how we pass data in. So just about every single, or I should say almost every single business rule is going to have these two variables that we pass in. And let's go ahead and document that one. So at function string to Boolean. Description. So we always fill out these description and headers. Converts a string to a Boolean value. Okay. And then we've got the variables here. So this one is a string. Most of them are going to be string because it is for string parsing. And basically a string that contains a truthy or falsy value and should be converted to a Boolean. Okay, and this one is also a string. Okay. And basically we're not using this one, not used for this business rule, but we do follow the standard template format. So, and finally, we just return a Boolean. Okay, so a Boolean value of either true or false according to the business rule conversion. All right, and then we sign it. Date. And note here for developers, we cannot pass in a 1 or 0 to this function and expect it to evaluate as a true or false because. So this is something to consider. We have another function that is passing strings into the function, and also part of that check to look for data types is a check to see if the string is a number. If a string is a number. So, sorry, I got my mouse messed up here. If we cause this function to evaluate a 0 or 1 to a Boolean, then the integer function would never get a chance to evaluate as a number. So that's why we have that limitation. So if you ever go to modify this function, then you have to take that into consideration. So the implementation here is let function name equal s dot, and this is part of our this is part of the standard format for how it's like a template for how we implement business functions as part of the framework. So we put the function here, string to Boolean. It's a constant. We're actually reusing that. We use that constant as part of calling this business rule. And then we have some logger functions. And so basically we're instrumenting this function with the capability for easy debugging. So loggers, it's like pre-implementing a debugging capability. Console log base file name plus b.c. This is part of the class name. So function name, which we just did defined above, and then s.c begin function, which is another constant we're using. So this, I think, is just declaring that it's the beginning of the function. And the class name is passed as a single string to the console log, so this is that class name. It's the base file name, which is right here, and the function name, which we defined here, which comes from this constant. So basically every single business rule will have sort of this format, loggers.console log, and then we do the same thing, base file name plus b.c, b.c plus function name. And then we have to log our inputs, so s.c input data is plus input data. So we've sort of predefined these messages, these standard messages that are used over and over again across the framework, across the business rules. And then we have another one. I'm just going to go ahead and copy paste this because it's almost identical. It's just the only thing that changes here is the instead of input data, it's metadata is, and then we have this input metadata goes right there. Okay, so now that we've written that, there's actually 2 more lines at the end that do the same thing. So we have loggers. I'll just copy paste again because it's kind of doing the same stuff. All right, and instead of having this as the message, it is documenting our return. So s.c return data is plus return data. And we haven't defined what that return data is, but we will in a second. I'm going to go ahead and put another one here, and this should change to s.c end function. And there's nothing else other than just that to finish it off. And then we return data. Okay, so now the implementation of this is pretty straightforward. If not input data, then we return false. Otherwise, let return data. So we define that return data. And we're going to just have a simple switch statement here. Lets us easily iterate over the input data. So input data dot to lower case. That way we're always dealing with a specific case. Dot trim. So make sure if there's anything else that has erroneously been passed in, we clean that up. Define that block, and we have a case g.c true. And we're going to just go ahead and define a whole bunch of these. Case g.c true. Case. I don't think that this is, I think we're doing two lowercase, so it shouldn't actually matter. G.c true. None of those should actually matter, but I implement them anyways. B.ct. And these are going to chain together. Case B.ct. Case B.cy. Case B.cy. And case G.c yes. Case G.c yes. And case G.c yes. Again, none of these should really all matter all that much, mostly because we have that two lowercase, but like I said, I implement it anyways, and it doesn't affect performance. If it ever did, or was ever shown to affect performance, then we could come back and modify this, but I don't think it ever, it never has. Case B.c on, case B.c on, and case B.c on. Okay, so that's basically our truthy. And, oh, why did I do that? I guess habit, I suppose. Okay. Okay, return data equals true, and we break. So we don't fall through to the next case statement. Okay, so then we have a case G.c false, case G.c false, case G.c false, case B.cf, case B.cf, case B.cn for no, case B.cn, and case B.cno, case B.cno, case B.cno, case G.c off, and let's see, did I get that right? Yeah. And let's see here, we got case, oops, case G.c off, and case G.c off. Okay. And then we do the same thing, return data equals false, and break. And then of course we need to have one more default case, which is just going to default. That'll be return data equals false, and break again. Of course, I don't think we need it because we're just, it's going to fall out anyways, but that's fine. Do it for code completeness. All right, so that's the end of that implementation. We move on to the next business rule. And this is why I said this is going to be long, because there is a whole lot of them to do. Export const string to data type. This is one we mentioned in that note above. Function input. We could just copy the rest of this. And actually, we can copy all of this all the way down to right there. So we'll just put that right there. And we need to clear out the end of it. So we're just going to copy paste all of this, because that's exactly the same. Okay, and the only difference here is just this part. So we got to put that here and replace that. Okay, and of course we'll go ahead and put our header in at function string to data type description converts a string to the appropriate data value. Okay. So if it's a string value of 3.1415926535897932384626433832, then it will get converted to a float of the same value. Okay, if it's a string value of false, then it will get converted to a Boolean of the same value. If it's a string value of 12, then it will get converted to an integer of the same value. Okay, if it's a string value of happy birthday, it will get returned the same as the input, no change, since it's just a string. If it's an array of strings or a collection object, it will get returned as the same as the input, no change, which kind of makes sense. Okay, then we got our parameters, so we're going to clean this up. And what are the parameter types? String, of course, because it's going to convert from a string to something else. The string that should be converted to some value. Okay, input metadata, not used for this business rule. All right, return. Well, we got to set the type first. Type can be an object, it can be a string, it could be a Boolean, it could be an integer, an array of whatever, whole tons of stuff. So that's fine. Return a value of whatever type the string should be converted to as appropriate. Oh shoot, I did that thing again. Okay. Sign our code and put a date. Okay. No additional notes needed. And let's go ahead and do the implementation. So we have the let return data. Need that. And let data type equal and determine object data type, and we just pass it the input data. So that's another function, another business rule actually that we're going to implement, because that can be also reused. So then we do a switch, same as before, data type, and we have some pretty basics here. Case w.c boolean constant, and then the return data equals string to Boolean. We have some custom parsing functions we're going to implement. Input data, so that does that, and then we break that to keep it from falling through. And these need to be pushed in. Okay. case w.c integer, return data equals parse int input data. So that's pretty simple. And we break. Case w.c float, return data equals parse float input data. And we break again. What else do we have? String, case w.c string, return data equals input data. Break. Default. We don't know what kind of object this is. Better return it the way it was, just to be safe. Okay. Return data equals input data, and we break. Perfect. And that's it. Okay, so now we got to go implement some of these custom parsers. The string to Boolean, well, we've actually implemented that right there. But determine object data type, that's something that does need to be implemented. Which again is going to be kind of the same. It's pretty simple. Just about every single one of these business rules is almost identical. Just the only thing different is the name and the implementation itself. So we have that, and then the ending comes out pretty much like that. These guys can come in a little bit, and well, we don't have this, of course. We'll have our own custom implementation here, and of course it's not string to data type, it's determine object data type. Okay, and we go ahead and put that here because we're going to have, with that constant is already defined, so we're just going to put that there. And I think that's it. The rest of this stuff, I think we're ready to do the implementation. Okay. Now, let's see, I kind of wrapped this up. The string to data type, and then this is the one that determines the data type. And we've actually got another set of functions that are actually going to do those individual parsing determinations. Let's go ahead and implement the header here. As usual, at function, determine object data type. Yep, that's it. Description determines if the contents of a string are actually a Boolean, integer, float, or string, or something else. Okay, then of course we got our usual parameters. This of course is going to be the same as the other one. It's just a string. Input data is a string that contains some value that we should figure out what kind of data type that data is. Boolean, integer, float, string, or something else. Pretty much same as above, just a little bit more verbose, make it clear. And input data is, we'll just put also a string here, but of course I don't think we're using this. So we just write not used for this business rule. Okay. Return. This is going to return a string. A string that indicates if the data type should be Boolean, integer, float, string, or something else. Sign it, and date. Okay, And the implementation is actually pretty close to the one above, just slightly different. If, instead of a switch, it's an if condition, is Boolean, and pass the input data. And I guess we just pass an empty string there, equals true. Then we're going to return data equals w.c Boolean. Okay. Else if is integer input data empty string equals true. Return data equals w.c integer. So just kind of following a pattern here, you kind of get the idea. Else if is float input data and the empty metadata equals true. Return data equals w.c float. Else if is string input data equals true. Return data equals w.c string. And then we just have a standard else block here. And I'm going to put some notes in just to be clear, so if anybody looks at this. Otherwise, we cannot figure out what the data type is. No real way to tell the difference between short, long, and double. Yeah, maybe there is, but I mean, we don't really need it, so it doesn't matter. And I mean, if there is a business need to do it, then we should be able to figure it out and find a way, but there isn't, and we don't really need it, and it is quite difficult to figure that out, so we'll just let it be. We don't really need to tell the difference between all those complicated. Okay. Yes, at least not yet. If we ever did, then we could take a look at that consideration. Return data equals w.c object. So we'll just tell it that it's an object coming back. Okay. And everything else is exactly the same. So yeah, there we go. Next, we're just going to start to implement some of those functions, which are pretty basic. I mean, they're just, there's a little bit here and there. So yeah, let's see here. Export const is Boolean equals function. And the rest of this, we're just going to copy paste from there, return data to right there. Okay. Is Boolean is what needs to change right here. And the rest of this, after we come down to there, is basically identical to that. Okay. All right, is Boolean. At function is Boolean. At description determines if the input string is a Boolean type of value, true, 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 T, Y, yes, yes, yes. One on, I guess one is Not really applicable here for the same reasons we had in the other discussion. On, or false, false, false. F, N, no, and no. And we're not going to have a 0 on there, of course. Okay, so the data types, we know that this is going to be a string coming in. Okay, the string that should be checked if it is a Boolean style value or not could be some form of true or false. There we go again. Okay. And the output, I think this is also not used for this business rule. String not used for this business rule. Okay. Return should just be a Boolean, same as the other implementation. A Boolean value of true or false to indicate if the input string is a Boolean or not. All right, and the implementation is just input data equals input data dot to lower case dot trim, and if input data equals g.c true, or input data equals b.ct, or input data equals b.cy, or input data equals g.c yes, or input data equals b.c on, or input data equals g.c false, or input data equals b.cf, or input data equals b.cn, or input data equals b.c no, or input data equals g.c off. Again, the case shouldn't matter, but good for completeness. All right, so if any of those are true, then we return data equals true. Else, return data equals false. And that's it. That's it. I mean, it's a little bit different of a logic here, and we wanted to do string-based comparisons instead of the other implementation. So it is a slightly different implementation. Feel free to let me know if you have comments about how to improve this. I'd be happy to take considerations. Maybe there is a better way. Maybe I can combine them. Very possibly could do that. So it's certainly worth considering. And then we have another implementation for export const is integer. Okay, equals function. Just copy paste this. Okay, is Boolean is integer. This needs to go right there. And we have the ending, which should be like that. Okay. And okay, we have, let's go ahead and write our header here. At function is integer. Description determines if the input string is an integer type of value and the number is minus 90072992547409992 to 90071992547409992. Yeah. Okay. And string, those are the upper and lower limits. Input data. The string that should be checked if it is an integer style value or not. Okay, and again, I think this one is string, but probably not used. Not used for this business rule. Okay, return type, same. Boolean. A Boolean, Boolean value of true or false to indicate if the input string is an integer or not. Date 2020 10/16. Okay. Is integer, those match up, perfect. And the implementation is just if is nan, not a number. I'm sorry, this has to take an input data. And then we need to do another check here. If input data mod 1 equals, mod 1 equals 0, it's a whole number, aka an integer. So return data equals true. Else, it's kind of a nifty little trick. Might be a number, but not a whole number. So return data equals false. And down here we're going to have an else case, because in this case the nan is not a number returned, did not pass that condition. Return data equals false. So it's just false, return it. All right. And you might be able to have other implementations, but this is a pretty clean one and I like it. So, and it works well. It's good performance. Not that performance really matters at this stage because we're dealing with such low level code. But we could always evaluate other implementations, like such as using an includes or an index of, or you can go on and do bitwise checking and other things. So, but anyways, all right. So the next one is export const is float equals function. And again, this is basically going to be the same. Right there. Okay, and then this is the same as well. All right. We got to change this before I forget it. Okay, all right. Save that. All right, so for the is float implementation, let's just go ahead and write our header here. Okay, at function is float at description determines if the input string is a floating point type of value or not. And again, we usually have the usual string data type. Okay, the string that should be checked if it is an integer style value or not. Okay, and we're not going to use this, of course. Not used for this business rule. Okay. It's also of type string. Not that we're using it, but it doesn't matter. And this should be a Boolean, just like all the others. A Boolean value of true or false to indicate if the input string is a floating point number or not. And the same, actually I made a mistake up here, is a floating point style value or not. Okay. And at author and 16. Okay. All right. Now the implementation of that again. Just if is not a number, input data, and input data dot index of b.c dot is not equal to -1. That should tell us if we have that decimal point in there. Return data equals true. Otherwise, return data equals false. Pretty straightforward. Okay. And the last one is string. Export const is string equals function. Okay. And again, just about identical to this. Following that, we have this. Okay, and then this one comes down here, is string. Okay, so write our header again. Function is string. Description determines if the input string is a string or not. By process of elimination, if it's not a Boolean and not an integer, and not a float, then it must be a string. Okay, there could probably be a possibly better way of doing that, but that'll work. It's worked for now, and it tends to be pretty reliable for my needs. The string that should be checked if it's is a string and not a Boolean, integer, or float. not used for this business rule. Boolean, and a Boolean value of true or false to indicate if the input string is a string and not a Boolean, integer, or float. Or not, meaning it would be one of those three data types. Yeah, one of those three data types disguised as a string. There, that cleans that up a little bit. Okay. And author and date. Okay. All right, those are the main ones. Now we get into some of the other business rules. This one is called export const single quote swap after equals. And our function, all of this is, oh, we forgot to do the implementation here. What am I thinking about? Forgot this implementation. If is Boolean input data empty string equals false, and is integer input data empty string equal false, and is float input data empty string equals false, and type of input data equals string, or input data instance of string. Then we do this. Return data equals true. If it's not a Boolean and not an integer and not a float, then it must be a string given the type of the variable is a string. But of course, we should remember that just because the type is a string doesn't necessarily guarantee that it is a string, because string numbers would still be of type string. So that's why that's important. And then of course we have an else here. Return data equals false. There we go. Okay. Now this one right here, a fairly similar implementation. Did I get this right? Yes, I did. Okay, and this one comes right here. So we make sure we get these function names correct. And then this part comes here. Okay. And let's do the header again. At function single quote swap after equals. At description swaps single quote characters in the middle of the string with double quote characters in the middle of the string. Okay, we got some examples here. Input name equals email address class equals username. Output would be something like input name equals email address class equals username. So we use this to do some of that parsing of the XML primarily, or any other data types that we're trying to process or load. Okay, this is a string input. A string that contains text with single quotes that should be swapped for double quotes. And this one is not used for this business rule. Okay, so we mark this one. And this should also return a string. A string that contains text where single quotes have been exchanged for double quotes. All right. If input data dot includes b dot c single quote equals true. I could just leave the true off, but I always like to be explicit with the code. First, replace all the quotes in the string with double quotes. So return data equals input data dot replace, and we've got a regular expression here, global b dot c double quote. And you notice that I'm actually calling another rule there. Okay. Next, replace the first and last double quote with single quote. If return data dot index of b dot c double quote equals return data equals input data dot replace b dot c double quote b dot c single quote. If return data dot char at return data dot length minus 1 equals b dot c double quote. These are some of those special cases that we have to handle in special ways. Return data equals return data dot slice 0 minus 1 plus b dot c single quote. Okay. Now, that's for that one, but we have an else case here too. Else return data equals input data. And that seems to work pretty good. Okay. All right, next one is, you can notice that we're actually calling a common function here. Is it? No. Sorry. Okay. Next one is export const swap forward slash to backslash function. The rest of this is the same down to about there. Okay, and actually the implementation for this one is a single line, and this is the one where we start to do I could probably refactor this one to use this same function. Equals replace character with character. Input data. And use another regular expression here. Forward slash backslash forward slash G for global. B.C backslash. Okay. And then we have a couple loggers and return the data. Make sure that gets formatted properly. There we go. And let's double check here. Single quote swap after equals. Swap forward slash to backslash. And we never actually got around to writing the header for this. That function swap forward slash to backslash. Add description. Swaps all forward slash characters in a string for backslash characters. Okay, and we've got some parameters here. Again, the usual string, input data, string that might contain some forward slashes. Okay. And I'm pretty sure not used for this business rule. It's going to return a string. Same as the input string, just all forward slashes slash characters swapped for backslash characters. There we go. Make sure that that's accurate. Yep. And we got this implemented. Okay, so for the next one, it's basically just the opposite of that. All right, so let's start the implementation of the reverse of this, which is export const swap backslash to forward slash. And again, it's pretty much the same. I think we might have a slightly different regular expression this time. Let's see here. Yes, instead of that one, it's that one. That should do it. The rest of this is the same. And all that we have to do is change this for this. Okay, and write the header. At function swap backslash to forward slash. Description. Swaps all the backslash characters in a string for forward slash characters. Okay. Input data string that might contain some backslashes. Oops. String, but not used for this business rule. And the return type, of course, is going to be string. The same as the input string, just all backslash characters swapped for forward slash characters. Okay. There we go. And next business rule, which is kind of similar. Export const swap double forward slash to single forward slash. And function, there we go. I think it's going to be basically identical. The only difference is we're going to have a slightly different regular expression here. So instead of that, we have to escape that. And pardon me. Okay. So we escape it, and then we need another one of those. Okay. And let me double check. Did I get this right? I think I might have messed this up. This should be forward slash, not backslash. That would have been confusing. Let's double check up here. Yeah, forward slash to backslash. There we go. Forward slash, that's correct. And then this one should be also forward slash. There we go. To single forward slash, correct. And then this right here is what goes on the end. Okay. Forward slash. And I think this one matches that one. Yes, but this one does not. So we have to map that down here. And write our header. Swap double forward slash to single forward slash, and description is double forward slash to single forward slash. So swaps all double forward slash characters for single forward slash characters. Okay, string. String. And not used for this business rule, of course, similar. Sometimes we will use it, but and it does form our standard template. String that might contain some double forward slash is. Okay. And then the return type, of course, is going to be a string. The same as the input string, just all double forward slash characters swapped for single forward slash characters. Okay, and then we sign it. There we go. And we got another one of those. I think this is the last one. Export const swap double backslash slash to single back slash. Okay. All right. And virtually identical for the rest of it. Okay. Now, this should change to backslash, C backslash, and this now changes from that ugliness to 1, 2, 3, 4. There we go. Yep, I think that's it. This needs formatting. There we go. And this probably has to change. Double backslash, yes. Okay. There we go. And the header function swap double backslash at description swaps all double backslash characters for single backslash characters. We need these functions to work with various paths, which is going to be needed when we start loading data. I think I might have mentioned that already. String input data string that might contain some double backslashes. We use it to clean up the paths and stuff of the paths that we're working with for the loader. String, and of course not used for this business rule. Return type is also going to be string, typical, the same as the input string, just all double backslash characters swapped for single backslash characters. Assign it and the date. Okay. Now that we've implemented all 4 of those, here's another nice little function, export const get username from email. This function pull all of that. Okay, we've got to make sure we set this up. And I think everything else is set there. Let's see here. Let function name equals, yes, get username from email. I need to log something else here. Okay, so I guess it's going to be the same as that. Well, yes, we do need some additional data here to log. Just thinking out loud here. This message is going to change. We're going to say index of the plus b.c at symbol plus is plus input data dot index of b.c at. Just for logging purposes, it's kind of a debugging thing, and it's only going to implement it if our configuration setting for this function is set up. So I'm not too worried about it. And then we'll have the return data. Well, here, let me come back down here to the implementation. I'm sorry, to the wrap, the close of the function. There we go. And then the return data equals input data dot substring, starting with first character 0, input data dot index of b.c at. That way we just get that part of the string. There we go. return data, and all I have left now is the header. At function get user name from email. Description converts an email input into a username. So that's a useful little key functionality. String a string that contains an email address value. Okay, and not used for this business rule. String. Okay, and we're also going to return a string. A string value of the substring from before the @ symbol. Author, date. Okay. It's fairly simple, good little things. And here comes another one. We're also going to use this. This is a key piece of our framework for the logging system. Export const replace spaces with plus. We basically turning delimiters and also part of the command system, I think. Function, and we'll just pull the rest of this. Okay. I think we've missed on the let return data. Yeah. Okay, so we've got that. This has to drop down to here. Alrighty, and we'll do the wrap up to right there. Make that our implementation. Let return data equal replace character with character input data, and we're going to just call this common function regular expression and b.c plus. There we go. So pretty simple implementation there. At function replace space with plus. I probably could do away with all of these functions and then just call this business rule and pass both of those things, but then I would have to always define these regular expressions, and I don't want those sitting out in my regular code, which is why I'm trying to put them into business rules so that my regular expressions will always be contained here. And I've tried to define these regular expressions into string constants, and that does not work because the regular expression evaluator and the way that these things are parsed, it doesn't work like that. You might be able to pull it off with some fancy business with Lodash, but I've just found that it's more trouble than it's worth to just leave it right here. Okay, so at description, okay, and this is replace space with plus, replaces all spaces in the input string with plus symbols. Okay. Input data, this is a string, of course, and this one is also a string. Okay, let's come up here. A string that contains spaces that should be converted to plus symbols. Okay. Input metadata not used for this business rule. Okay, return type should be a string also. The same as the input string, but with space characters converted to plus symbols. Assign it. Okay, and that that covers it. Okay, and I think we got another one of these that's kind of similar. It goes like this. Actually, there's just a few more. Only this one, and I think maybe one more. Export const replace colon with underscore. Okay, function. All of that business. Did I get this right? Replace space with plus. Yes. Okay. Just double checking my work. And this one, the regular expression, should change to a colon here. Still global. And this should now see C underscore. There we go. Okay. And this needs to change right here. Okay. And then we'll do the wrap up on the function with the ending part. There we go. I think that looks just perfect. Yep. Okay. Now, at function, replace colon with underscore at description. Replaces all colons in the input string with underscore symbols or characters, however you want to describe it there. String. Okay. Input data. A string that contains colons that should be converted to underscore symbols. Yeah, another thing I tried to do was parameterize this so I could actually like include the character that I was looking for. That didn't really work out very well either for the same reason that I mentioned before. Okay, string input metadata, and this one also not used for this business rule, and that's fine. Okay. I think we also have a string here, the same as the input string, but with colon characters converted to underscore symbols. Assign it. $20, $10, $16. Okay. And that should be accurate. Yep. And colon with underscore. Okay, double check that work. And I think we have one last one. Export const replace character with character. It's actually this implementation of this function right here. Equals, and then we're going to have the function with the rest of this. Return data, and I think we might have a little bit more to possibly consider doing. Yes, we do need to implement a slightly different system here. Okay. Let character, well, here, before I get into the implementation, let's double check this and maybe go ahead and write our header. Okay, and let's write the header. At function, replace character with character. Description. I think we have some extra notes here. Replaces all of a specified character of a specified character in the input data with another specified character. Okay. Yeah, okay, so this is another thing. Yeah, at note. This is an interesting point to consider. This is not a public-facing business rule because the function signature cannot be made to match with the except, well, actually, it is matching. What am I thinking? This is matching input data and input metadata. I don't see what, maybe this is just like a copy paste error that I don't want to include. Okay. Yeah, I think because of the way this changed, it's not an issue anymore. I think this can actually be a public facing function. Input data, I'd have to see how we actually set this up, but I know this is going to be a string, and I know this one is an array of string. So we have to have that for sure. Let's double check this input data. A string that may or may not contain the specified characters that should be converted to another specified character. And this is an array of data that contains 2 additional string parameters. And we're going to document that right here. Input metadata 0 equals character to find. Essentially, oops, the character to be searched and replaced from the input string. Okay, input metadata 1 equals character to replace. The character that should be used to replace the character specified for replacement from the input data. Okay, and then the return is going to be a string also. The same as the input string, but with specified characters converted to the other specified character. And then we sign it. There we go. Now the implementation of this is, like I said, a little bit different. Character to find equals input metadata 0, and let character to replace equal input metadata 1. Okay, and instead of having like this, we'll have input data like that, and not character to find, and not character to replace. That way we sort of cover CYA on that one. Return data. Oh, before we do that, let's go ahead and call the wrap up here. Okay, and let return data equals input data dot replace character to find with the character to replace. Pretty simple there. That try to make it as easy as possible, and we should be good. Make sure we save all of this. Okay. Let's see here. Yes, we have to do a few more little things. Here's another one that could actually be somewhat similar. I don't know. Let's see. I can play with these a little bit later now that I'm seeing that there's some commonality here. Okay, hold on a second. All right, so another one to do is this export const clean carriage return from string. So it's also kind of the same. Probably could have called this function, but I have implemented basically the same exact thing. This needs to change. Clean carriage return from string needs to come down here. Okay. And instead of having these, and we're not going to have that. We're not going to have this or that. Input data is fine. And let's make sure we wrap this up with the corresponding end. Okay, now instead of having this input data dot replace, it's just going to be a regular expression s plus g. And this part right here just looks like that. And then finally, we do a dot trim on the end. Okay. Clean carriage return from string. And then we just have to write our header. Add function. Clean carriage return from string. Description. Cleans carriage return characters from the input data and trims off any leading or trailing spaces. Okay. String. String. And the string that should be scrubbed for carriage returns. Not used for this business rule. And of course it's going to return a string. The same as the input string, but with all carriage return characters removed. Assign it. Okay. And that's it for that one. Next one is convert string to lowercase. Export const convert string to lowercase. Function all the way down to return data. Okay. Clean carriage return from string, and this is convert string to lowercase. Okay. Return data equals, okay, that'll remind me that I need to actually come back and implement that. Let's put the end of the function on. Input data dot to lowercase. Pretty simple. I know you could probably just do that directly, but having it as part of a business rule means that I can chain it. And that's where the real power comes in with implementing all of these little tiny modular functionalities in this business rule system. At function, convert string to uppercase. Add description. Converts the input string to the same string but with no lower case letters. String input, string, and may as well just change this one as well. String. Input data is the string that should have all lowercase letters changed to uppercase letters. Input metadata not used for this business rule. Okay, oops. corrected string with all uppercase letters. Sign it. Okay. And then we'll have basically the exact same function. Wait a minute. Did I just... two lowercase? Yes. This should be lowercase. Did I get that wrong? Lowercase letters to lowercase. To lowercase, lowercase. And then we'll have the exact same one that just does the uppercase. Just copy paste this whole thing. And to uppercase. Converts the input string to the same string but with uppercase letters. Uppercase. All the this one is backwards. Okay. Should have all uppercase letters changed to lowercase. And this should have all lowercase letters changed to uppercase. And the corrected string with all uppercase letters. This should change to upper as well. Let's just copy paste from there. Uppercase, and this as well to uppercase. To uppercase. There we go. And that should work now. Okay. Next is, yes, we have more file and path related ones. Export const get file name from path equals function and all of this. Same as usual. Okay. Get file name from path. And the wrap up. Okay. Get file name from path. Let's go ahead and do this header. That function get file name from path. Description gets the file name from a string that contains the path and the file name. This should be string, string, and string. Input data, the string that should have all the folders and path removed from it. Not used for this business rule. Oops. Yeah, okay. The file name and file extension string without the full path. Sign it. Date. Okay. Now the implementation. Yes. Let's put a comment in here. Clean the path string for any double slashes. That way we have a clean slate to work from. And yeah, before we do let the return data, let's go ahead and clean up that input data. If not input data dot includes b.c double forward slash. Okay. Input data equals swap double forward slash to single forward slash. We're going to pass it the input data and empty string. Okay. And if input data dot includes b.c / then input data equals swap / to / input data empty string. Okay. Oops. Yeah, there you go. Okay, we got let return data right here equals input data dot split b.c / dot pop dot trim. Nice little trick there. And then of course the return data, and that's it. There we go. Yeah. And get file extension is the next one. Export, oops, export file, export const, sorry, get file extension. Okay. Just do that. Okay. And then let return data equal. Okay. But I have to make sure we do this first. We don't want to mix this up. I've made that mistake in the past. And we'll go ahead and put the wrap up on the function. There you go. And we'll put the header in there. At function get file extension description. Parses the file name, and it may or may not also include the path. But regardless, it gets the file extension of the file. Okay. Let's clean up here. String, string, and string. Okay. Input data is the string that should contain the file name to which we want to get the file extension from. Okay. Input metadata not used for this business rule. Return is the file extension such as txt, xml, csv, etc. Assign it and the date. Okay. Now the implementation, path.extension name, input data. That's pretty simple. All right. Next one is export const remove dot from file extension. You'd think we would be done with these by now. Okay. Get file extension, remove dot from file extension. Function remove dot from file extension, and the description removes the dot from the file extension, such as if the input is .txt, the return value will just be txt. Okay. String, string, and string. Okay. The string that should contain the file extension that is being modified. Not used for this business rule. Typical. And the return string is the file extension without the dot prefix. Assign it. Okay. And we'll put the wrap up on this function again. Same as all the other ones. Okay, that one needs to come over. Oops. Okay, there we go. And the implementation of this is input data.substring1. There you go. And we got one more to go. Okay, export. Did I get this right? Remove dot from file extension. Always double check your work when you're writing code. Sometimes even triple check your work. Okay, export const remove file extension from file name. All right, function. Oops, see, double check. That's why I missed that. Would have had to pay for that later. Okay. Remove file extension from file name. Okay, perfect. That needs to go right here. And we'll put the wrap up on this one. Okay. Let's go ahead and put that header on. At function. At function. There you go. Remove file extension from file name description. Removes the file extension from the file name if it is there. Otherwise, it will remove all the characters after the last period in the file name. Okay, clean that up. And string, string, and string. Input data is the string that should have all the characters after the last period in the file name removed. And, oops, data, input metadata not used for this business rule. All right. I told you this was a pretty big library. The same input string, but without the file extension or all the characters removed after the last dot. Sign it. Okay. And the implementation, ooh, yeah, this could also do that replace function call, but this will be just fine. Input data dot replace regular expression. It's kind of an interesting way of writing this. Plus and $, followed by that guy, and then those two. Let me double check that, make sure I got that regular expression correct. / period open square bracket caret / period close square bracket plus $sign / comma. Perfect. That's what we want. Remove file extension from file name equals function. Remove file extension from file name. So, yep, that should do that. We still have a few more functions to implement. I think we're actually probably about halfway through. So I think I'm probably going to have to make this a part 1 and a part 2. So let's make sure, let's save this. We got a good portion done. We got a lot done today, but we still have quite a bit more to go just on this string parsing alone. So let me go ahead and call it quits, and we'll wrap up the second part with a subsequent episode. All right, thank you. If you find this video helpful, please click the like button below and click the subscribe button and the bell to be notified when new videos are published. This also helps me out and lets YouTube know that you enjoy my videos. Thank you very much.